As always, of course, it's great to be back in front of the Angelbeat community for another great session of Tech Talks. I always love the opportunity to come and talk and evangelize about security. Hey everyone, my name is Steve Woodard. I'm a cloud strategist and evangelist for AWS, located in Tampa, Florida. I've been at AWS a little over 3 years, and during this time, I've had an amazing opportunity to work with customers and really enable them on their cloud journey. And really, when I talk to customers, one of those topics that really is front and center is always the topic about security. And at AWS, security is job zero. It's our highest priority. And as of course you've seen in the headlines over the last couple of weeks or even the last couple of months, the most recent cyber attacks have a tremendous impact in kind of how we're all looking at securing workloads from any perspective, whether you're big company, startup, enterprise customer, whichever. And this really shows us that everyone needs to be looking at new and innovative ways to keep those critical workloads protected from these type of attacks. In previous Angelbeat talks, I went into depth around specific security services and tooling. And I really want to kind of shift the conversation now a little bit. And I want to talk more about the strategy and mindset for when we talk about security and how we engage with our customers, and really the benefit of how they can improve their security posture by leveraging what we call the AWS well-architected framework as a guideline specifically around the topic of security. And Woodard, our famous CTO, basically really said it best. If you want your customers to build workloads that are trusted by their customers, then they will have to demonstrate security across a broad range of scenarios. And really, AWS provides a series of services, a whole entire ecosystem, or what we call a full sleeve offering of services, which are specific in nature that can really work to address a wide range of security challenges from our customers, regardless of their size and industry. So let's set a scenario. So let's say, for example, you and your team have worked for an extensive amount of time, and they have built out this architecture that's highly available, resilient, fault tolerant, all the good stuff baked into it. And now all of a sudden management comes and says, hey, we need to have the InfoSec team to conduct an audit of that environment to ensure that there's no vulnerabilities, and we need to make sure that we do this prior to moving into production. A lot of people who are very familiar with kind of an AppSec process or just moving a workload into production are very familiar with, right? And typically what we see from our customers is they want to be proactive in this. They don't want to have something get flagged by security saying they don't have the proper security control. So what our customers typically do is they reach out to their AWS solutions architect and they ask for help, and they ask us to perform what we call a well-architected session. And they want to specifically look at this from a security perspective or a security lens on how they can enable the framework, whether that's how they can leverage the framework to better harden the workload or better to secure the workload. And this could be workloads running either all in the cloud. This could be workloads that run basically in a hybrid environment. So some of this could be running in the cloud, some of this could be running on-prem. It doesn't really matter. The purpose of the well-architected framework is really to help customers understand the benefits and the risks of the decisions about what they need to do when they're building workloads in the cloud. And the framework really provides what we consider to be our architectural best practices that we have gained from working with thousands and thousands of customers over the last numerous years, and how we build reliable and secure and efficient and also cost-effective workloads. And it really provides a consistent way to measure those operations against best practices. So if we take a look at the 5 different pillars of the well-architected framework, we launched this back in 2015. We launched the AWS well-architected framework, and really that was to help customers ensure that they have all the information they need in order to make or in order to build highly available, resilient, and secure architectures in the cloud. And this really consists of things such as key concepts, design principles, architecture best practices for running those workloads in the cloud. In 2018, we launched the well-architected framework tool that customers can now access directly inside the AWS Management Console. And that really kind of builds upon that, the framework really builds upon the 5 pillars, right? So that's operational excellence, right? The ability to run and monitor systems, security, the ability to protect the information, all of the assets when delivering business value through a risk assessment and looking at specific mitigation strategies. And we've also got reliability, so the ability to recover from an infrastructure or service disruption, performance efficiency, the ability to really use those resources to meet those requirements, and then also cost optimization, which is the ability to run those systems to deliver business value at the lowest price point. And really today we want to focus on the security pillar. The security pillar is specifically about protecting information and systems, and really how do we make sure that we keep those topics confidential? How do we ensure the integrity of the data? How do we identify and specifically identify, and how do we manage who can actually access that data? When we talk about privilege management, we'll talk about basically protecting systems. And also it works for customers because we also want to talk about establishing controls for how to detect security events, right? So I think one of the questions was, how do you start getting into an event-driven architecture so that way you could start kind of being a little bit more proactive in terms of reactive in terms of responding to security events. These are all very important concepts. These are all very important conversations we have with customers. First thing I want to hit on is that we talk about the secure shared responsibility model. Again, we talk about this with our customers. Customers are responsible for what they put in the cloud, so they're responsible for what they put in the cloud. So things such as the customer's EC2 instances, the VPCs, S3, you think of it kind of as infrastructure as a service. And really the point here is that the customer has to perform all of the necessary security configuration management tasks as they deploy resources in the cloud. They are responsible for the management of the guest operating systems, such as updates, security patches, known vulnerabilities, things like that. And any application or any software that's installed by the customer, really they're taking over the responsibility here. So if they're deploying things such as firewall or IDP, IPS, they're responsible for that as well. And AWS is responsible of the cloud, so that's basically the hardware, that's the regions, that's the availability zones, that's the edge locations. Those are all of those things AWS is responsible for. So when we align those security services across what we call 5 ethics of the well-architected framework, it really begins to kind of help our customers understand how these tell a story. So when I talk to customers about moving their most valuable workloads to the cloud, it really is important for them to understand really that AWS is a full suite of offerings that customers can enable on day one. That really not only help them strengthen their security, but also enables them to kind of innovate faster when it comes to being able to change, or if in fact their security needs change. And AWS offers the most extensive cloud-native solutions on the market today. So every customer should look at, if we look at this from a perspective of, every environment should start with embracing a sound identity and access management type of solution. That's basically, how do you authorize those users to gain access to a specific resource? And this could be either done through leveraging something simply as a single sign-on. This could be through LDAP, through directory services, or you could even leverage something such as Cognito for those web and mobile applications. So once those users are then authenticated, you need to be thinking about how you're going to monitor that activity. And we have services where we can enable something such as security now and guard duty, and those can now come into play. And the benefit to this is that you can leverage these tools because now they're built with machine learning into it, where they can look at and examine and report on normal and abnormal user activity. Now that we've done that, we can now look at making sure that we can protect those resources from things like distributed denial of service or DDoS attacks. And this is where something such as AWS Firewall Manager and Shield come into play. And these services really add that additional layer of protection, such as layer 3, layer 7, layer 3, layer 4, and layer 7. And then finally, when we're looking at incident response, we need to be thinking about how can we respond to abnormal behavior, right? So it's not only just important that we detect abnormal behavior, but what does that look like, right? We need to be thinking about how we can add in a capability that gives us additional protection and also builds in some additional remediation processes in place here. And also, when I talk to customers here, we talk about incident response. Always love to talk to them about Amazon Detective, which really makes it easy for them to not only analyze, but investigate and then quickly identify things such as root cause and potential security issues, things that are suspicious activities, right? So it looks at your normal trend and it looks to detect suspicious activities. And the nice thing about Detective is that it's going to automatically kind of ingest those logs from various AWS sources. use the machine learning. It's going to apply a machine learning model against it. It's going to give us a statistical analysis, and it's even going to provide us with a graph theory to really kind of look at a series of linked data sets that really enable the customer to kind of easily conduct a faster and more efficient security investigation for things that are basically alerted on. Now, when we look at the well-architected framework, we hit upon a series of design principles, and there are 7 design principles inside the security pillar. And when we're determining if a customer's security posture is adequate, we really need to look at, the evidence for each principle for which they kind of apply in the architecture. And we'll basically go through kind of each design principle and provide an example of where it can be applied. So number 1, of course, we talked about implementing a strong identity foundation. This is really where we talk about the concept of least privilege to really enforce the separation of duties that really only require a privileged authorization that each user has an interaction with each of your AWS resources. And this could be, hey, you may want to centralize identity management and really aim to basically eliminate resilience on long-term static credentials, right? So we may want to talk about things such as password rotation, or we may want to talk about enforcing strong passwords. These are all things that we want to talk to our customers where when they start thinking about implementing a strong foundation, how are they currently doing this today? And when we talk about implementing a strong identity foundation, we want to align the services which are categorized, such as things such as identity access management. And we ask the customer, do you need to implement a single sign-on technology or a single sign-on methodology? Do they require password-based management that would really benefit things such as separation of the environment into your accounts? All of these items can really be asked during a well-architected review to assist the customer in producing a security posture, which really helps them understand exactly kind of what is the specific risk they're using within their environment. And it really provides kind of an overview as to kind of that workload, because workloads we know are never easy. They are going to become complex. And what we really want to do is help the customers understand this toward a more trajectory or a more kind of focused trajectory. And we have a wide range of services that allows customers those flexibility, right? So you've got identity access management where you can create users, groups, roles. You can even create policies. You can also leverage AWS SSO, which now if you're using SAML based IDP, you can basically then integrate that into your provider of choice. So this could be something such as Okta or any other type of SSO provider out there. But you can now basically grant the access to their users, from the users to the resources here. And then as the organization scales, you can leverage something such as AWS organizations that really provide, number one, it provides visibility, and it provides visibility across all of your AWS accounts and provides you with a centralized policy management that allows them to really kind of look at all of your accounts, look at primary accounts, look at child accounts, and then be able to provide policies based around those specific accounts. And if you take this one step further, as organizations begin to scale, right? So you think about how we can start to leverage, policy of least privilege. Resource Access Manager is a really nice feature because what it does is it really provides a central repo for where you can share pieces of subnets. You can share out things such as License Manager to basically make sure that configurations within other accounts are compliant. And the benefit here is that it eliminates the need to really provision duplicate resources in every account that is a multi-account environment. And again, the benefit of taking this further is that it reduces the operational overhead of managing additional resources at every account, which is really, really cool. So let's look at an anti-pattern when we talk about this concept of overcrowding here, right? This is an example of what we call a, kind of overcrowding. So if you look at this example, initially the environment is made up of, use within a single VPC, that shared account structure that runs various different workloads. And basically each team is going to own different parts of the operational and the overhead of this architecture. But the problem is that as the workload matures and you add more and more services together with each of these employees managing them, the complexity begins to be a problem here as well. Also, the problem here is that you've got all of these numerous workloads here in one single account across a couple of VPCs. So what happens here is that this basically starts to say, all right, so let's take a look at your blast radius. The blast radius is if this single account gets compromised, all of these accounts are therefore compromised. So that is something that we really advocate for customers, is looking at your blast radius to determine exactly what is your risk appetite. Again, we talked about basically here, again, this is the same concept here, is that if in fact, if this organization or is this basically account gets compromised, or even if in fact if the account gets audited, right? So who's at risk, who's the rightful owner? And it really, when we start to see this with customers, it really becomes a very difficult to answer because there's no real lines of demarcation within the environment. And it's really difficult to really see what's actually going on. So as a best strategy, we take the same concept, we kind of take a look at it and we say, all right, so this is a much better process. This is a much better type of perspective, right? So minimum access for each team within an account with logging to be essentially published to an account solely for a specific purpose. Each workload can be permissioned with its own individual access. And ultimately, we can enable logging, which makes traceability much, much easier. So now we can take a look at that from a logging perspective and really get into the details here. We talk about enabling traceability. So this is where we talk about customers about monitoring, alerting, and looking at the audit changes in the environment in real time. And what we want to do is we want to integrate those logs, and we want to look at metric collections to investigate each and every action. So we talk about detective controls. AWS has a suite of detective controls. We talk about as a recommended best practice when you talk with customers, we really want to encourage them to build an environment where traceability is possible throughout the entire architecture. So CloudTrail, for example, is a service that allows you to track all those users, all the user activity and API across the environment. And what we do is we want to make sure that customers understand, listen, you want to enable CloudTrail to make sure it's turned on in all regions, and that you have configured the specific VPC flow logs. Together with that, you can basically now have components that can present data from load balancers to databases. And in addition to this, you want to really kind of see what you can automate in terms of specific checks using config, which is another tool, AWS config, that allows you to look at events and logs, and then you can even escalate to your InfoSec team based around automation rather than manual efforts. And we'll talk about that a little bit more in detail. So we talk about security, applying security all layers. We want to talk about basically kind of apply a defense in-depth approach within multiple security controls. And this could apply to all layers. We talk about edge networks, VPC, load balancing, every instance, every compute service, every operating system, every application, every layer of code. We want to be able to provide this. So let's kind of build this out here. So we want to make sure we use the full use of security of multiple layers of infrastructure, right? So we talk about CloudFront. We talk about being able to leverage this to provide against a DDoS, or basically a DDoS strategy. That we can also include WAF, which is our web application firewall, within the VPC to reduce those surface attacks from access load balancers. You can add an access load balancer, and you can now also provide a network access control layer and security groups appropriately. So now we're starting to build this out here. Now we're talking about building out a NAT gateway. We now have some Lambda functions running in the background. And now we start finally getting into our private subnet, which is now basically handling our most critical data, which is our customer data. Anything that's within a database, that should be listed in the private subnet. The concept here is only to expose as little as possible. And this could be basically your only thing you expose is your application load balancer. So we would talk about practices, our best practices here. We talk about being able to create network layers, control traffic at every single layer. So every single layer here is going to basically, traffic is going to flow through multiple layers of segmentation. And then we can also implement inspection and protection. So now we can also inspect all that inbound and outbound traffic that's going into and out of our resources. So let's talk about automation. When we talk about automation, it's very important that we talk to customers about automating security-based security mechanisms. And what we mean by that is we'd love for you to say, all right, wouldn't you love to be able to improve your security scale more rapidly and more cost-effective? Wouldn't you love to be able to create architectures and then really kind of really include and implement controls that are defined, that are managed via code and version control templates versus having someone kind of do this manually? This is where we start getting into the whole entire, DevSecOps type of methodology. And as customers begin to continue their cloud journey, it's really important that they learn how to build a mechanism for how to automate specifically the responding to security events. So let's say, for example, there's a customer who wants to basically say, hey, I want to be able to combine available controls, I want to combine incident response concepts, and I want to be able to say, I want to identify cloud capabilities, service mechanisms, and then basically build upon those. And then really the main benefit here is that they can start small, they can iterate, you can adopt, you can add, remove services, and you can use these to improve the response need so that you're better prepared for when the security events sort of basically occur. So some services that are really powerful for this are leveraging something such as AWS config rules. And really what this does is this really allows customers to create custom rules that can automate the action in response to changes in an environment. A really good example of this would be as, let's say, for example, is that let's say someone or something basically adds a public IP address to an EC2 instance or attaches an elastic IP address, therefore giving it access to the internet. And really this is a security no-no, right? Since you want to have a security best practice would be as you expose as little as possible that's accessible to the public internet. And then once that rule match is detected, it's detected this change, you now can allow AWS config to trigger a Lambda function that can automate and quickly respond to the security event. And then what it can do is that Lambda function then can basically go out and remove that elastic IP address or that ENI or that IP address to that specific attached instance. Or if you want to take it a step further, is that you could shut the instance down as well too while you perform some sort of quarantine and inspection on it to see kind of what happened. It's entirely up to you. The benefit here is that customers now can basically build these into their entire incident response procedures here. Another anti-pattern we look at is manual technical auditing, right? So manually Go team, basically looks at and they basically can run and conduct interviews. The problem with this is that it's very time consuming and it really doesn't scale. So if you're doing internal audits and they don't run as frequently as they should, well, maybe we'll get to them every quarter, maybe we'll get to them every 2-3 weeks, well, maybe we got some meetings, we just don't make it to it here. The shift here we want to talk about is being able to move towards an automated audit with AWS. This way, it takes that manual intervention out of the equation, and now we can start to implement more of a continuous automated auditing. So this is an anti-pattern. So both the cloud adoption framework and the well-architected framework, right? Because we all love frameworks. We combine the cloud adoption framework and the well-architected framework, and what it does is it really kind of provides a recommended approach for how customers can improve their procedures on incident responses, and then they can even test those run books before an incident. So now as we start to get into this, we can now start to say, all right, we're going to test these processes before an incident occurs, and now we can decrease the time it takes for you to respond to when an actual production environment happens. And when you look at the tools customers have available to them, not only just in AWS, but basically kind of looking at across the industry here, is that you look at the process of auditing, it really becomes easier when you are running continuous compliance mechanisms such as config, which really provides a record of not only how long you've remained in a compliant state, but basically exactly when you deviated from it and what happened. And then through that immediate access to evidence, specifically through the auditing trail, the audit simulations really becomes easier to manage because now we can funnel those issues through kind of a lens where we can look at it in real-time notification, and we can respond appropriately with an appropriate remediation. And ultimately, as the best practices, the goal of any DevSecOps team is to basically secure a pipeline that they design and automate. And then what they can do is they can embed application development knowledge, and they can also use automation tools and processes in every security team so that way they can provide security at scale. So if we look at some of these things here, we look at cloud conformity, we look at cloud custodian. There's a wide range of tools that are available to customers inside the continuous detective controls environment. So protecting data in transit, we look at how we can talk about classifying your data, and we talk about data classification, so that way we can classify the data into sensitivity levels, and then customers can build a mechanism such as encryption, tokenization, and access control where possible. And we have a wide range of security. Again, we are definitely not short on a couple of these here. Two things I want to hit on basically here is that Customers want choices. Customers want choices when it comes to adding automatic detection or data encryption into their cloud architectures. And really, two services we want to deep dive into basically here are something like Secrets Manager. And Secrets Manager essentially is a secrets management service that really helps customers protect assets or access to those applications. So this enables you to basically rotate, manage, retrieve database credentials, API keys, and other secrets through basically a lifestyle. So really, it's kind of like, what's the password to the password type of saying, right? So you can use Secrets Manager so that you can rotate those secrets, manage those secrets, and that could be basically either third party, that could be on-prem, that could be in the cloud. Secrets Manager works with both. And really how it works underneath, really Secrets Manager encrypts at rest using encryption keys that the customer will own and that they store in KMS. So now you can control the access to the secret keys using IAM and KMS. So when you retrieve a secret, Secrets Manager is going to decrypt the secret and it transmits it over TLS to your environment. And basically by default, Secrets Manager does not write or cache secrets to persistent storage, so it's a firewall. And then they can even leverage something like Macie, where Macie is going to use machine learning and look at a pattern matching to look at and discover whether or not any type of sensitive data has been placed into an S3 bucket. So if you're a healthcare company, if you're looking for any other company that's looking to protect PII, such as names, addresses, credit card numbers, this service is really powerful because what this allows you to do is it allows you to define your own custom sensitive data types. And then now what you can do is basically discover and protect that sensitive data as the data gets dropped into real time, and it'll basically alert you to let you know. And of course, with multi-accounts, so as your accounts grow, you start getting into more multiple accounts. The great thing about Macie is that now you can basically have a single Macie administrator that can perform tasks that span across the organization. So as your organization scales, as you get more complex, the great thing about Macie is that it basically can be performed through a single managed API operation. Keep people away from data. We want to talk to customers about, think about using mechanisms or tools to really reduce or eliminate the need for direct access or manual processing, right? So we talk about this concept. We want to reduce the risk of mishandling or modification of human error when managing sensitive data. Really here we talk about really keeping people away from data reduces the chance of corruption of your original data source, specifically through inadvertent changes. You can basically look at it this way, right? So first, we're going to use effective use of APIs where appropriate. So this could basically be the predefined data that's accessible to the users. And then via adequately permissions, there's a permission model whereby the original data source is queried by a service such as Lambda to retrieve information in a secure, read-only manner. And then secondly, you can also use another automation piece that's specific to an artifact for a third party. So if you have to provide information to a third-party auditor, regulator, or for example, let's just say you need to provide access to this for an audit. So you can provide access to this through a trouble ticket, through Jira, PDFs through S3. There's a lot of different ways you can do this here as well. Prepare for security events. We talk about preparing for an incident by having an incident management investigation policy and process that aligns with an organizational requirements. And what this essentially means is that we want to make sure that those incidents, you run those game days in conjunction with your tools to really increase the detection investigation of the company. And we've talked about the concept of being able to be prepared for these events by running game days. It's basically the concept is, hey, you want to make sure that you play out these common scenarios and play out how you're going to manage data spill, how you're going to manage misconfiguration, how are you going to manage all of these things here, right? So if someone changed your security group on a Friday night, how long would it take for you to notice and what would be needed to correct the change and remediate the accordingly, right? So when we talk about this with customers, we want to talk about and evangelize the concept of running game days because this enables them to be better prepared for when they do have an incident that actually works with inside their incident response team as well. And I'm low on time here. I got basically one last slide here. Again, we talk about these design principles, and these design principles really here talk about implementing a strong identity foundation, traceability, security all layers. Best thing is to have these kind of in the back of your head at all times and approach every problem with these in mind. And this is what we talked about, is having a well-architected environment that is secure and compliant. And lastly, of course, we've got a couple of links out here, so some resources for some further reading, including some blogs that are updated in the most recent security pillar. Definitely a lot of information out there. If you're thinking about running a well-architected review of your environment, it's accessible through the management console. It's a series of questions. You take that, you look through that, and it provides you with a series of AWS recommendations on how you can improve your security posture in your environment. And with that, I think I'm at the top of my time, and back over to you, Ron.